Gonzalez, and I'm here to introduce a commonly recognized technology law called Moore's Law. With regards to Moore's Law, I would also like to address the main questions of whether Moore's Law is reaching a limit to modern chipsets. Moore's Law was first stated or observed by Gordon E. Moore in 1965, who was a co-founder of Intel. This law refers to the pattern of processing speed of the computer chip for computing hardware. This pattern, of which transistors could be placed on an integrated circuit, was predicted through previous technological advancements and observations of doubling every 2 years. This observation of the doubling of transistors increasing speed and increasing of technology was just originally a prediction of how integrated circuits and modern chipsets would become, and this simple observation became the motivating factor for technology innovation, thus resulting in social changes and altered significantly the individual's daily life and the computer as a tool. Moore's Law, in essence, is an exponential growth rate for technology advancements for the computer, and as such has allowed it to be compatible to reflecting processing speed, memory capacity, and functions such as those which can be linked to other digital devices. So as we can see, Moore's Law has now been applied to multiple different circumstances for which are exponentially predictable for growth. Now, with regards to the question of whether Moore's Law is reaching a limit for modern chipsets, it's kind of detailed to a more complicated answer than just plainly yes or no. Based on Gordon Moore's original conditions in which the prediction became a law, we are in fact peaking. CPUs are starting to hit the end of such exponential growth. For modern chipsets, the limitation as to how much can be fit into one chip has become a critically hindering point for keeping Moore's Law in effect. Additionally, in pushing to increase performance to measure up to Moore's Law, there are problems that need to be taken care of, such as excessive heating problems because there are so many more circuits that are crammed into small spaces. Even though, on the surface conditions for when Gordon Moore predicted this theory of exponential growth are reaching their carrying capacity, the idea, I believe, remains the same and has not met its limit. Therefore, even though CPUs are at its end, so to speak, regarding the number of transistors which can be put into the modern chip, CPU's graphic processing units are currently beginning to grow at an exponential rate. Our chipsets consist of hardware of having 4 cores. However, currently we can only use maybe 1 or up to 2 cores with most software. Therefore, the technology for hardware exists, but in this scenario, the software has not yet caught up to using multiple cores. So the cores themselves cannot get any smaller or faster, causing them to hit the wall of Moore's Law. But since we are adding multiple cores per processor, this will continue the idea, not literally, but in accordance with today's technology, keeping with Moore's exponential growth factor. Therefore, some people could, will, and do debate the fact that Moore's Law has indeed reached a limit with modern chipsets. But the reverse is also accurate in saying that Moore's Law has only altered with its time and continues through newer means of speeding up technology. In addition to the exponential rise due to multi-core per processors, researchers are considering nanotechnologies or quantum computing to replace modern silicon-based chips to quicken processing speed and efficiency. Dr. Moore, however, has stated that the idea of using nanotechnologies make him skeptical because it is essentially building things atom by atom, causing a chance of mistake or alteration. In conclusion, I'd like to ask something. What do you believe? Do you believe that Moore's Law has reached a limit with regards to modern chipsets? Do you believe that with the use of multi-cores being used in computers, like cell phones where certain cores are used for specific software, it has and will keep Moore's law alive? Or do you believe, as Gordon Moore himself stated, that in terms of size of transistors, we're approaching the size of atoms, which is a fundamental barrier which is leading to the end and limitation for modern chipsets? The debate is still up. What do you think? I believe that laws need to be maintained, but as all ideas, morphed and altered over time to fit the environment. Thus, I believe the expansion of technology for moving into using multi-core processors will let Moore's law of exponential growth continue on. And this concludes my podcast on whether Moore's law is reaching a limit for modern chipsets. Thank you for listening to this informative podcast. Goodbye!